Question 8, it says use a scale of 1 centimeter to 1 unit, which is what I have done. 1 centimeter is equal to 1 unit. We are using a 2 by 2 scale, and draw the graphs of the following equations. From the graph, find something. So first let's plot the graphs. 6y is equal to 5x plus 10, which means y is equal to 5x plus 10 upon 6. So if x is equal to 4, y will be equal to 20 plus 10 upon 6, that's 30, which means 5. So if x is equal to 4, y is equal to 5. If x is equal to, I notice in the denominator is 6, I will have to keep increasing by 6. So x is equal to 10, y will be equal to 10 into 5, 50, plus 10, 60 upon 6, which is 10. So if x is equal to 10, y is equal to 10. And if x is equal to, let's say, negative 2, y will be equal to negative 10 plus 10 upon 6, which is 0. So negative 2 with 0. So let's plot this first. So I have negative 2 with 0, which is this point. Next is 4 with 5, which is this point. And then the last is 10 with 10, which is this point. So let's join these 3 points using a scale and a straight line. Your graph would look better than mine because I do not have access to a scale here. I extend an arrow and I write this as, this is 6y is equal to 5x plus 10. Perfect. Let's look at the next equation. The next equation is y is equal to 5x minus 15. So if x is equal to 3, y will be equal to 15 minus 15, that's 0. So x is equal to 3, y is equal to 0. X is equal to 4, y will be equal to 5 into 4, that's 20 minus 15, that's 5. So x is equal to 4, y is equal to 5. And if x is equal to 5, y will be equal to 25 minus 15, that's 10. So x is equal to 5, y is equal to 10. Let's plot these 3 points. So 3, 0, 4, 5, and 5, 10. Let's join them using a scale and a straight line. So let's join this and let's join this. Perfect. Extend it on both sides, arrow on both sides, and write the name what we've plotted. We've plotted y is equal to 5x minus 15. To find the point of intersection, we will draw a dotted line on both x and y axis. So solution set is equal to 4, 5. You can also write this as xy is equal to 4, 5. So let's look at the parts of the question. It says the coordinate of the point where the two lines intersect. We've already figured that out. The area of the triangle between the lines and the x-axis. Oh, so let's give this name A, give this name B, and this give name C. So they want the area of triangle ABC. Again, we know this is equal to half into base into height. In this case, it will be half into base. Base, let's take as AB. And what would be the height? If I draw a perpendicular from C onto the base, so this is a perpendicular, let's give this point name D. It will be AB into CD, right? So this will be half into AB, which is how many units? 2, 4, 5 units, right? Negative 2 to 3, that's 5 units, and the height is again 5 units. So 5 into 5, so that's 25 upon 2 square units, which basically is 12.5 square unit. So the area is equal to 12.5 square units. That brings me to question number 9, one of the most important and interesting questions of this chapter. You can put a small star on that question. Let's read it. The cost of manufacturing X articles is rupees 50 plus 3x, which means cost price is rupees 50 plus 3x, and the selling price of X articles is rupees 4x. So selling price is given by the equation selling price is equal to rupees 4x on a graph sheet with the same axis, which I've done, and taking suitable scale. So we'll figure out the scale. plot two graphs, first for the cost of manufacturing against number of articles, and second for the selling price against number of articles. So on the x-axis we'll plot number of articles, and on the y-axis we will plot cost price or selling price in rupees, increasing this way. Perfect. So that's what we'll plot on x and y. Use your graph to determine something. So let's first plot and then we'll figure out what we need to do. So if x is equal to 0, which means no articles are being produced, cost price will be 50 plus 0, that's rupees 50. Now if I'm not producing any articles, why do I still have a cost price? I'll give you some time to think about it. And if x is equal to 10, cost price will be equal to 50 plus 30, that's rupees 80. So that's 10 and 80. And if x is equal to 20, my cost price will be 50 plus 3 into 20, that's 60, that's rupees 110. So 20 articles will cost rupees 110. Let's look at selling price. So if x is equal to 0, which means I'm not making any cost, I'm not selling anything, my selling price will be 0. I don't make anything, I don't sell anything. Ix is equal to 10. If I sell 10 products, my selling price will be 4 into 10, that's rupees 40. So 10 and 40. If I sell 20 products, my selling price will be rupees 20 into 4, that's 80. So 20 and 80. Let's plot these points. So I notice that x is increasing by 10 that I've taken. So on the x-axis, let me take each unit as 10. So that's 10, 20, 30, 40, 50, 60, 70, 80, 90, and then the last one can be 100. On the y-axis, I have to go at least up to 110. So let me take multiples of 20. So this will be 20, 40, 60, 80, 100, 120, 140, 160, 180, 200, 220, 240, and the last one 260 in rupees. Let's plot. So 0 with 50, that's the middle point of 40 to 60. Did anyone figure out why we will still have a cost of 50 rupees if I'm not making anything? Well, I still have to pay salaries, I still have to pay the electricity cost, I still have to pay the rent. So that's even if I don't manufacture anything, I'll still have a cost. Next is 10 with 80. So 10 with 80. Next is 20 with 110, which will be between 100 and 120. So here let's join these 3 points and extend them using a scale. Now you would be able to get this line much better because you will have a proper scale. I do not have access to a scale here. This line that I have plotted is CP is equal to rupees 50 plus 3x. Next, let's plot the selling price. So 0 with 0, 10 is with 40, 20 is with 80. These are the 3 points that I have. Let's join them using a straight line, using a scale, and also join them using extend them using a scale. So that's here. If I extend it, this should pass somewhere from here, here, and if I keep extending, it will pass from here, and then it will go from here. So this is my selling price is equal to rupees 4x. Done. I have plotted it. Now let's see what are the questions that they want. They're saying number of articles to be manufactured and sold to break even, which means there is no profit and no loss. So no profit, no loss means cost price is equal to selling price. In this case, where do these two lines meet? That will be the cost price is equal to selling price. So number of articles, and this is at article number 50. You will draw a dotted line from here onto the x-axis, because x-axis is where we are plotting number of articles. So for no profit, no loss, number of articles is equal to 50 articles. Perfect. So this is 50 articles where I have no profit, no loss. Next, look at this. This is 50 articles. So here I am on the x-axis, and then the cost price and the selling price at that point will be rupees 200. So here this is what I have plotted. Next is profit on 30 articles. So let's look at what will be the profit on 30 articles. So from 30 I draw a dotted line onto my cost price first. When I draw it to the cost price, my cost price is 140. So I went from the x-axis, went on to the y-axis, and on the selling price line, my dotted line goes to 120. So this is basically my profit, but in this case it's loss because cost is more than selling price. So profit on sale 30 articles is equal to loss of rupees. How much is the loss? 140 and 120, that's rupees 20. So the loss of rupees 20. So this is basically the loss of rupees 20. Profit on 60 articles. Let's look at 60 articles, and now I will draw a dotted line from 60 articles which I have plotted on the x-axis onto both selling price and the cost price. Now let's see if I have profit. The first line that I touch is the cost price line. Oh, so which means I am having a profit. The cost at this point is 230. Perfect. I will draw a dotted line from here and it reaches here. This point that is 230. And let me extend this to my selling price, and then I draw a dotted line onto the y-axis. This is 240. I put an arrow here, so my profit here is this much, which is rupees 10. 240 minus 230, so profit on 60 articles is rupees 10. That's about it. I'll see you in the next question. Question number 13 says, use the graphical method to find the value of x for which the expressions 3x plus 2 upon 2 and 3 by 4x minus 2 are equal. So these two expressions are equal and they want us to plot graphically. But if I remember correctly, to plot graphically, we need two variables, x and y. So how do I do it? Now, common error would be students would end up solving this algebraically, which means they will take LCM, cross multiply and find value of x. They'll give you a direct 0 mark because the question clearly states use the graphical method. So let's take the assumption, let 3x plus 2 upon 2 is equal to y, which is also equal to 3 upon 4x minus 2. Now we get two equations, y is equal to 3x plus 2 upon 2 and y is equal to 3 by 4x minus 2. Now we have two variables and now let's plot them. So the first one, so if x is equal to 0, y will be equal to 3 into 0, that's 0 plus 2, 2 upon 2, which means 1. So this is x, this is y. If x is equal to 0, y is equal to 1. X is equal to 2, y will be equal to 3 into 2, 6, 6 plus 2, 8, 8 upon 2, 4. So x is equal to 2, y will be equal to 4, and x is equal to negative 2, y will be negative 6 plus 2 upon 4, that's negative 4 upon 4, which is negative 4 upon, no, not 4, this is 2, in the denominator is 2, my mistake, but this is 2, so negative 4 upon 2, which means negative 2. So x is equal to negative 2, y is equal to negative 2. Let's plot these 3 points. So negative 2 with negative 2, that's my point, negative 2 with negative 2. Next, 0 with 1. Yeah, and then the last one is 2 with 4. 2 with 4. Let's join these 3 points using a scale. Extend it slightly on the other side. Let's look at the other one. Y is equal to 3 by 4x minus 2. So if x is equal to 0, y will be equal to negative 2. So x and y, x is 0, y is equal to negative 2. Next one, x is equal to 4, y will be equal to 3 by 4 into 4 minus 2, that 3 minus 2, which is 1. So x is equal to 4, y is equal to 1. And if x is equal to negative 4, y will be equal to 3 by 4 into negative 4 minus 2, that's negative 3, and negative 2, that's negative 5. So negative 4 with negative 5. Perfect. Now let's plot these 3 points. So 0 with negative 2, which is here. Next is 4 with 1, which is here. And then the last one is negative 4 with negative 5. Let's join these 3 points using a scale. Please note that my graph may not be perfect because I am using freehand to draw them. Let's extend this line as well and see where they intersect. So this line, the first line that I drew was y is equal to 3x plus 2 upon 2, and this line was y is equal to 3 by 4x minus 2. Where do they intersect? For which value of x do they intersect? For the value of x that they intersect, since they want only the x value, I will draw a dotted line only to x, and the value of x is negative 4. Therefore, for x is equal to negative 4, 3x plus 2 upon 2 is equal to 3 by 4x minus 2. The only key or the only important or a different part was there was no second variable, and you took this equal to y, this also equal to y, and then you plotted. And one more thing, in this answer, the solution set they want is only the value of x. So again, I plotted a dotted line only to the x-axis. This brings us to the last question of this exercise, question number 14. The course of an enemy submarine as plotted on rectangular coordinate axis, so these are the rectangular coordinate axis, gives the equation 2x plus 3y is equal to 4. Okay, so this is an enemy submarine, right? Enemy submarine is using this line, a marine. So it's moving along this path on a straight line. On the same axis, a destroyer's course is indicated by the graph this. So this is a destroyer which will destroy the enemy submarine. Use the graphical method to find the point at which the submarine and the destroyer intersect. So again, let's look at this. This can be written as 3y is equal to 4 minus 2x, which is my enemy submarine path. Y will be equal to 4 minus 2x upon 3. So let's take some values of x and find value of y. So if x is equal to 2, y will be equal to 4 minus 2 into 2 upon 3, which is 4 minus 4 upon 3, which is 0. So if x is equal to 2, y will be equal to 0. Next one. Since the denominator is 3, which means I will have to increase my value of x by 3, either on the positive side or on the negative side. So if x is equal to 5, value of y will be equal to 4 minus 2 into 5, that's 10 upon 3, that's negative 6 upon 3, which means negative 2. So if x is equal to 5, y will be negative 2. And then the last one, if x is equal to negative 1, y will be equal to 4 minus negative 2 into negative 1, that's plus 2. So 4 plus 2 upon 3, that's 6 upon 3, which means 2. So x is equal to negative 1, y will be equal to 2. Let's plot these 3 points. So what I have is negative 1 with 2. That's this point. Negative 1 with 2. Next is 2 with 0, which is 2 with 0. And then the last is 5 with negative 2. 5 with negative 2. Let's join these 3 points using a scale and a straight line. Yeah. And extend it on both sides and see where this is the what I have plotted is enemy submarine, and this is 2x. This is moving in a straight line, which is 2x plus 3y is equal to 4. Let's plot the path of the destroyer. This will be y is equal to x minus 7. If x is equal to 0, y will be equal to negative 7. So x is equal to 0, y is negative 7. X is equal to 2, y will be 2 minus 7, that's negative 5. So x is equal to 2, y is equal to negative 5. And if x is equal to 4, y will be equal to 4 minus 7, that's negative 3. So x is equal to 4, y will be equal to negative 3. Let's plot these 3 points. So 0 with negative 7, that's here. Next is 2 with negative 5, which is here. The last one is 4 with negative 3, which is here. So the destroyer is just about to intersect the path of the enemy submarine, and this is where they intersect. To find the coordinates, I draw a dotted line onto the x-axis and also to the y-axis. This is 5, this is negative 2. The coordinates will be 5, negative 2. So use the graphical method to point at which they intersect. So solution set will be 5, negative 2, or xy is equal to 5, negative 2. That brings me to an end of this chapter. Homework questions would be question 3, 4, 7, 10 and 12. Thank you. I'll see you in the next video.